Hi, welcome back to Cereal Killers, the podcast all about the pest diseases, weeds and challenges of arable crops. I've actually already recorded this podcast once, but I bored myself senseless. And if I was boring myself, then I would definitely be boring you. So I'm going to do this one and hopefully put a bit more interest and fun into this topic, which is BYDV. I'm going to make the Barley Yellow Dwarf Virus as entertaining as I can get. So it's autumn, and at this time of year, farmers would be trying to control BYDV virus on their crops, their winter wheat crops that they've recently established. However, it's been so wet out there that no one has drilled or sown their crops, and so there's no need to control BYDV yet. So this is a timely podcast where if you're sat around doing nothing, then you can get ahead of the curve and look at potentially novel ways of controlling this very, very serious disease of cereal crops. And it's such a serious disease that you can lose up to 60% of your yield in winter wheat or 50% in winter barley if you don't control it. And that's massive. And the reason why you get such bad losses is because there is no cure for BYDV once it's in your plants. Plants don't have an immune system. So unlike COVID, which I'm currently suffering from, my immune system will fight off COVID eventually. However, a plant can never fight off BYDV because it doesn't have an immune system. Also, there are no virucides available for plants, for any crop. They're not even something that's on the horizon that could potentially be there soon. The closest thing we've got to a cure for viruses is it's sort of like RNAi technology, and that's pretty far off. So certainly in cereal crops. And then it's questionable whether it would actually be effective in the field. So you can't control it. The plant hasn't got an immune system to fight it off. And so once it's there, your losses are tremendous because the virus is sucking the energy out of the plant, getting it to produce more virus particles rather than actually producing yield. And unusually for a virus, it can actually kill the plant as well. So normally viruses really harm the plant, but actually leave it in a state of sort of stress and ill health rather than actually killing it. Whereas this one, if you get the virus in young plants, the young plants will actually die. And as the name suggests, it produces yellowing or chlorosis. As scientists, we don't like to say yellowing because it's not yellowing, because yellowing implies something has gone yellow. Whereas actually, when plants are chlorotic, they've lost their greenness. So a better way is to say chlorotic. But yellowing is the name of this one. Dwarfism is another symptom, and then you get red tipping of the leaves in older plants as well. That's another symptom, but that can be confused with things like phosphorus deficiency, where you get a purpling of the leaves and other things. So just like a GP looking at symptoms, you need to sort of have a holistic approach and look at the context to see whether that yellowing or red tipping or dwarfism is down to a virus. You'll get patchiness. Patchiness is in your crop, is symptomatic of BYDV. And that's because the virus is transmitted via aphids. And so when one aphid lands, you get hot spots in the crop rather than just the whole crop or just one plant. Eventually the whole crop will succumb to it if it's not controlled. So everything around BYDV centers on aphid control, because the aphids are what's causing to infection. One aphid can infect more than one plant, and they propagate on the infected plant, and then more aphids are produced. So you need to control the aphids, and then the most obvious way of controlling that is with a insecticide and with a pyrethroid-based insecticide. And that goes on in autumn after establishment, and that's why we're doing this podcast now, because this is the time when most people are thinking about this virus. Okay, so there are a couple of aphids that are the major causes of BYDV, or the major vectors, as we would say in science. The first being the South Cherry Oak aphid, and the second being the North Grain aphid. And unless you're an aphid expert like Tom Pope, my friend Tom Pope, there's no real reason to know those different species. That the way you treat the disease is not going to be affected by which aphid is attacking it. Okay, so control the aphid, control the virus. There are other ways of controlling the virus or helping control the virus. The aphids will be coming in from field margins, but they'll also be coming in from green bridges. So that could be a weed or a volunteer cereal plant in the field. And then the aphids will, once the previous crop has been harvested, the aphids will have been shook off the plant and will be in the soil, and they won't die immediately. And so if you sow your seeds too quickly, then that can provide a green bridge as well. So leaving 5 weeks between cultivation and sowing is recommended. And in this year, that's not going to be an issue at all because of the soil's been so wet, the weather's been so wet. So annual meadowgrass is, as we said in a previous podcast, it's not a major weed. It's not going to reduce your yields, but it will be a source of infection for this. So destroy annual meadowgrass and volunteer cereals. Late drilling, min-till also is thought to reduce infection. And then it's one of these things where direct drilling will be beneficial. And that's because when you're direct drilling, you're going to have a much higher beetle and spider and other natural biocontrol agents in the soil and the environment, and they will eat the aphids as they go. So anything you can do to encourage natural predators of the aphids is going to be good. And then also you can get BYDV-tolerant varieties. So especially in recent years, a number of varieties have come to the market, and these are on the AHDB recommended list. There's KWS Ferris for winter barley and RGT Wolverine for winter wheat. There may be others that, since I looked at this, that have been released or variants on this, and that's always a good opportunity to exploit if they suit your conditions. And the HDB, as well as recommended list, they provide fortnightly updates on aphid and thus the risk of BYDV in the summer, and then weekly updates in the autumn, so you could see where that takes you and what your risk factors are. Syngenta, or as well as providing the insecticides for this, and other companies provide insecticides, they also have an app that puts in your location data, the weather data, and data from traps, and that you can sort of forecast your risk of BYDV. When you look into the science behind the virus a bit more, it gets very complicated very quickly. So there are a number of different variants, not varieties, and isolates of this virus. Some affect all cereals, others are distinct to one particular crop type, like oats. And so it's not a case of just one particular virus. There are a number of different variants out there. However, the control method for them all is pretty much the same. There's also the cereal yellow dwarf virus, and that sounds very similar, and it affects the same crops, and it's transmitted by some of the same aphids, and it's got similar symptoms, and it's related, but it's still a distinct virus. And so the science behind viruses gets really complicated very quickly. But the good news is you don't actually need to know a great deal about it to get good control. So there you go. The reason why BYDV is top of mind for me at the moment is because our blackgrass spores, our pathogenic spores for blackgrass, we're actually putting an extra spray of them on this autumn, because we were at the Agravista AgX event, and I'm speaking to a lot of the farmers and the agronomists there, and they were saying that this would be a really good time to apply the spores because they could go on with the insecticide because there'd be no compatibility issues. And also, at that time of year, there are no fungicides going on the crop. And obviously, we struggled in the spring with our pathogenic spores because it was so wet that everything was delayed and everything had to go on very, very close together. And so we were putting fungi on at the same time as a fungicide. And so that sort of limited its effectiveness. So now we're going to go on with another batch of spores on all the farms that signed up for on-farm trials. And we're going to put them on with the insecticidal spray. And so hopefully that could yield really good results because there's not going to be the fungicide there. The other thing is that potentially it will weaken the blackgrass plants during the winter, and so they could potentially die off and be outcompeted by the cereals come the spring. There is also a potential downside of it in that the plants could become sort of immune to the blackgrass pathogens. The blackgrass plants could become immune to it. So that's why we're doing the trials, because we don't know which one, the positive effect or the negative effect, is going to be seen in the real world sort of situation. So we're really excited about that. If anyone listening has been following the blackgrass pathogenic spore project, that as of today, that's now open for more farms to get on board and start trials. We've really ramped up production in the lab, and every week we find a new way of producing more and more spores. So we're going to go on with more and more spores next year, and hopefully introduce some more blackgrass specific pathogens as well. So it's a really exciting time on that front as well. And which is good news because blackgrass is not going anywhere anytime soon. And then the last point about BYDV is that there's a real symbiosis between the plant and the virus and the aphid, in that when the plant's weakened, that helps the aphid in its ability to suck sap out the plant, and vice versa. So scientists believe that the sort of symbiosis, and they've evolved together, and they actually the aphid encourages the virus to be in the plant because a weakened plant suits both parties. So there's that symbiosis as well. If you've got any other interesting facts about BYDV, then please get in touch. It's not the sort of thing that we can take pictures of easily, because you're really only taking pictures of the symptoms. You need an electron microscope to study viruses, and even then you get a pretty rubbish picture because they're so small. But yeah, that was BYDV. Not the most interesting of subjects, I'll admit, but a very timely subject to cover. And I don't know what we're going to cover next. Probably something on our list. Go for probably an insect or a fungus next. Okay, thank you very much.